Hi, I'm Rob, and for you placer miners out there, I'd like to give you a brief history in the use of the Assay Ton system. The reason for this is that the Assay Ton system is really a big part of any of your assays. You're probably trying to figure out exactly what you're going to get off of your placer mines. The amount of gold that maybe you're going to be expecting, along with some of the silver and so on. And the Assay Ton system really does play a big part. So in this presentation, I'm going to give you a brief history, and then we'll go through some of the calculations that are actually involved in using the Assay Ton system. Although fire assay has been with us since the days of the pharaohs, eons ago, the estimation of your precious metals within the ground has been always a troubling issue, especially in the areas of the mathematical methods that were used for the calculations, which in turn is used to derive the estimates and therefore is prone to error. In order to mitigate this problem of errors and to simplify the method of calculation, a fellow by the name of Charles F. Chandler at the Columbia School of Mines, way back in 1886, developed a system known as today as the Assay Ton system. This is actually a system of weights for assaying those precious metals in your ore and in your concentrates. Which is it? Is it a short ton or a long ton? AT it is for Assay Ton. In essence, the Assay Ton system, abbreviated as AT, is really a combination between two avoir systems and a French metric system. The system also has an inherited potential error. You see, what happens is in use, one needs to actually know which avoir system to use or is used, as both will have the abbreviation of AV behind the ton. Okay, which is it? Avoir or avoir du poids? The English system is known as avoir du poids, whereas the North American system is just simply known as avoir. Well, back in the day, Chandler based his system on the Troy grain avoir du poids. There are 7,000 grains per pound avoir du poids. Hence, we have two avoir systems. We end up with two different mathematical results. Now, the English ton system, the English ton being AV, contains 2,240 pounds, avoir du poids, and is known as the long ton. The North American system, or the North American ton, being the short ton AV, is only 2,000 pounds, avoir. Both are written as 1 ton AV. Depending on where you are in the world, you need to know if the long ton or the short ton is being used, especially if you're buying bullion from England or North America. Okay, about the calculations. Well, the English ton, as you know, contains 2,240 pounds, avoir du poids. It is known as the long ton. The North American ton, avoir, is 2,000 pounds. Both are written as 1 ton AV, avoir. Depending on where you are in the world, you really need to know if it's a long ton or a short ton that is being used. In Europe, the long ton is used. So let's look at the European long ton. There's 7,000 grains in 1 pound. And of course, LB is the abbreviation for the pound, and it's the same as the North American pound. Therefore, If we got 2,240 pounds times our 7,000 grains, we get 15,680,000 grains in 1 ton. Avoir du poids. There are 480 grains in 1 troy ounce. Of course, it's written as 1.0 ounces troy. Therefore, if we have 15,680,000 grains divided by 480 grains, we get a magic number of 32,666.666 ounces troy in 1 ton. Avoir du poids. You got to remember that this is a long ton. Okay, this is where the French metric system comes into play. As you know, there's 1 million grams in 1.0 metric ton, written as T-O-N-N-E. Gram in the old textbooks is spelled as gram, G-R-A-M-M-E. So how does this work? Now, it's been shown that there's 32,666.66 troy ounces in 1 ton, avoir du poids. Now, each gram of metal obtained would indicate 1 ounce troy per ton, avoir du poids. Now, if we've got 32.666 grams of material that we process, and we ended up with 3 grams of metal, gold for example, each milligram would indicate 1 ounce troy per ton, avoir du poids. And this is how the French metric system and the avoir du poids systems are combined. Okay, here's the relationship. If we took a few samples of an ore body, or it could be samples off your placer claim within a certain area, it would be assumed that these samples are coming from 1 assay ton of ore, or ground of interest. Now, after you take that and you fire it, or you sieve it through a set of screens, and the result obtained was 1.2 milligrams of that precious metal, it would be reported as 1.2 ounces troy per statute ton. In this case, avoir du poids being 2,240 pounds. Okay, alternatively, using the North American short ton at 2,000 pounds, avoir, the same methodology is used or incorporated. We know that we got 7,000 grains in 1 pound. Then 2,000 pounds times our 7,000 grams gives us 14 million grams in a short ton. As there's 480 grains in 1 ounce troy, we can then find that the 14 million grains divided by 480 gives us 29,166.66 ounces troy in 1 ton avoir. Much like the English system, the French system component is also put into play. But we got 29,166 troy ounces per ton. And this also indicates that each gram of metal obtained is equal to, like I said, 1 troy ounce per ton. So if we've got 29.167 grams of material processed, and it resulted in 1 milligram of metal retained, it would equal to 1 ounce troy per 1 ton. So if the weight of your prill, or from the ore being your pickers maybe, which it came from, and it weighed out, let's say at 1.2 milligrams, it would be stated as 1.2 ounces troy per 1 ton AV. But in this case, as the previous example, one would need to know which AVOR system is being used, as there is actually a difference between 1.2 ounces troy per 2,000 pounds and 1 troy per 2,240 pounds AV. So how big and where did the 1 milligram per 1 ounce troy come from? Well, the assay ton is shown is made to weigh 29.166 grams or 29,166 milligrams. Now, knowing that 1 troy ounce equals 31.10 grams, the 1 milligram is accomplished by taking your grams at 1 ounce troy divided by the 29, which should equal out to 1.0 times 31.10 divided by the 29.166 will give us 0.001066 grams, or 1 milligram rounded off. Now that 29.166 grams, of course, times 1,000 gives us the 29,166 milligrams. Well, in any case, you can actually see and say that 1 troy ounce of short ton is the same as 1 milligrams per 1 assay ton. This gives us the magic number of 29.166. It can be represented as followed. The grams divided by the 29.166 will give us our assay tonnage. Now this brings us to a second magic number. It is derived from the metric system. Since 1 ounce ton, being a short ton, is equal to 1 milligram at 29.166 grams, then our 1 milligram at 29.6 times 1 times 10 to the 6 grams, which is equal to the 1 ton, times the 1 gram divided by the 1,000 equals 34.286. An easy number to remember because it is a constant, very similar to the 29.166 grams. In the next few slides, we'll show you how this is actually used. Okay, the reporting of the troy ounce per ton at 2,000 pounds is always determined by the weight of the sample and the weight of the sample after processing. Let's say we had a bunch of samples put together and the weight of the samples total was 30 grams. And after they were all processed, the metal or the gold retained after the processing was 25 milligrams. Well, we're looking at 0.025 grams, but we need our AT weight. So our 30 grams divided by our magic number, the constant 29.166, gives us our AT weight. Therefore, we can take our AT weight, divide that into our 25 milligrams, and we end up with 0.024 ounces troy per ton. Okay, using the previous slide, we came up with a reported value of 0.24 troy ounces. Well, the relationship here is quite simple. Since we had a troy ounce in a short ton, that would be equal to our 1 milligram divided by the 29.166 grams. That in itself equals to 1 milligram per 1 AC ton. Therefore, it would be 1 ounce per ton AVOR. Now, most assays today are reported in percentage, parts per million, or even parts per billion. This is based on the metric system. So we can use the figures that we got from the previous slides. So if we wanted to know what the grams per ton actually was, we would take our 0.24 troy ounces and we would times it by that magic number, that constant of 34.286. That would give us 0.83 grams per metric ton. That would be 0.83 parts per million, or 0.83 divided by 1 million times 100, or 0.000083%. A pretty small figure. If I was a miner, would I want to mine that for that low of a concentration? This is why we use the Assay Ton system. Okay, let's go a step further. Now, the figures below, either one can actually be used. It all depends on the country that you're relating to. The grams from the short ton was calculated from the following. The 1 milligrams, the 29.166 times the 1.0 time, which is equal to the 6, which is equal to 1 ton, which gave us times the 1 gram, or 1,000 milligrams, gave us that magic number of 34.286 grams per ton. Okay, but the long ton is a little different, because we ended up with 1 milligram equaling to 32.666 times the 1 million grams for the 1 ton times the 1 gram at 1,000 gave us 30.612 grams per ton. Okay, let's put this into some perspective. After firing a charge, let's say it's a 30-gram charge or 30-gram sample, we ended up with a 5 milligram bead. Using the long ton system, this would indicate that there was 0.004 troy ounces. Well, knowing this is a long ton, the grams per ton can actually be calculated. The ounces per ton is equal to the 0.005 grams that you received in the bead. But we need an assay ton figure. And we know that that assay ton constant for the English ton is 32.666. So if we get the 30 grams, divided that by 32.666, we get our AT figure, our assay tonnage. Then by taking that assay tonnage and dividing that into the 0.005 milligrams of ore sample processed, we would end up with 0.00544, or 0.005 ounces troy per ton. Now this estimated weight or concentration would be 0.01665, or 0.166 grams per metric ton. That's derived by the 0.00544 times a 30.612, the magic number, which gives us the 0.166 grams per ton metric. Because it's grams per ton, 1 gram is 1 part per million, we get 0.166 parts per million. Generally, the reporting would have given us in parts per billion. So parts per billion would be equal to 0.166 times 1,000, which would give us the 166 parts per billion. That way, if one needed to, or is required to convert the parts per million or parts per billion to troy ounces per ton, this can be easily accomplished, since we know that 1.0 parts per million equals 1.0 grams per ton, or 1 gram per ton. Then 1.0 parts per billion equals 1,000 parts per million. Okay, if calculations were made using the short ton, The value that you would be using for the magic number would be the 34.286 grams per metric ton. This is what you would need to use. For example, if we needed to know what the ounces per troy per ton was, showing a report of 400 parts per billion, then the 400 parts per billion would equal out to 0.400 grams per metric ton. Since we're looking for ounces per ton, we would take our 0.100 grams per ton divided by the 34.286. We would end up with 0.117 ounces per troy, or troy ounces per ton. However, in this case, you would still need to know if it was a long ton or a short ton. For the long ton, you would be using the constant 30.612. Now, this pretty well concludes this particular presentation, and in future presentations, we'll be using these figures a lot more. In the meantime, I'd like to refer you to some of the references used in preparing this material. First is Nuggets to Neutrinos by Stephen T. Mitchell, Notes on Assaying and Assay Schemes by Ricketts, Pierre de Peyster, 1848 to 1918, The Sampling and Assay of Precious Metals by Ernest Alfred Smith, and the BCIT Student Manual of Fire Assay. The calculations have also been produced, and some of the picture material is referenced by Ernest Fred Smith's book, The Sampling of Assay of Precious Metals, page 14. Now, additional material that is used in the references, as references, page number 30, I believe it is. This is from the Notes on Assaying and Assay Schemes by Ricketts, 1848 to 1918. Additional material and references used can be viewed from The Sampling and Assay of Precious Metals comprising of gold and silver by Ernest Alfred Smith. These particular references that I'm referring to on page 59 and 60. Well, this concludes the presentation on the brief history of the Assay Ton system. If you like this video, please give it a thumbs up. My channel is designed for education only, and we don't try to sell anything. If you like this presentation, again, give it a thumbs up. I'd like to conclude by saying thank you for watching. The next series will probably be on fire assay, what it is, how to conduct a fire assay, the reagents used, and so on. So keep in touch. Bye for now.